Okay, so occasionally our graphs have what we call holes in them, and they are just simply gaps in our graph, and they are only created when we have the same factor on the top and the bottom. So whenever I see a rational expression, it's a good idea to factor it. So I'm going to get x minus 1, and this is going to give me x minus 1 times x plus 2. And can you see that I have the same factors on the top and bottom, x minus 1 and x minus 1? So if the factors cancel, all we do is we say that whatever value I would put into that factor is going to be the x value of my whole. So I'm going to have a whole, I'm going to have a whole at the value 1, and I have to find my, my y value. So everything else, the rest of our graph is all going to come from the simplified graph, which is just 1 over x plus 2. So it's still a rational expression. Make sure you put that 1 in the numerator here. Don't just do x plus 2. So it's 1 over x plus 2 is what's left. And all of our typical questions, our horizontal asymptote, our vertical asymptote, our x-intercept, our y-intercept, and our domain, they are all going to come from this simplified, this smaller rational expression, which is nice because I have less to deal with. I don't have to deal with something as big and as ugly as this. And including also the y value for my whole is also going to come from the simplified expression. If I were to plug 1 back into the normal expression, I would get 1 minus 1, which is 0 on the numerator, and you would always come up with 0. So that's, if you're always ending up with 0 down here, you know that you're making a mistake because it's going to come from this smaller expression. So now if I plug my x value of 1, my 1 into this expression, can you see I'm going to get 1/3? So this is going to give me positive 1/3. So what I'm going to do is right away, I'm going to go down to my graph and I'm going to go down to 1 1/3, and I am going to put on my graph an open circle. That's just going to remind me that when I do draw my graph, I need to skip that spot. So I'm going to still draw my, my normal graph as always, but when I get to that spot, I'm just going to skip over it because it's like this big giant chasm that you can't go through. Okay, so let's just, from this smaller expression now, let's answer our normal questions. So my vertical asymptote comes from the denominator, so I have a vertical asymptote at -2, and my domain restriction tells me that x cannot equal -2. I am going to have my horizontal asymptote, well this is bottom heavy, so that's just y equal to 0. When it's bottom heavy, it's always y equal to 0. My my y-intercept is going to be positive 1/2. That's where I plug 0 in for x, so I get 1/2. And my x-intercept, well, if I set this equation, if I set this guy equal to 0, all I'm looking for is to set my numerator equal to 0, right? Well, 1 can't equal 0, so that tells me there's none. There is no x-intercept. So now let's just go over to our graph and graph this guy. So I've got a vertical asymptote at -2. I've got a horizontal asymptote at 0. Okay. I have a y-intercept at positive 1/2, which is going to be roughly here. And now, so can you see that I've got, 2 points going on in this quadrant, so that's enough for me to graph this guy. So I'm just going to go through, my x-intercept, I'm going to stop at my whole, and I'm going to continue on. So just skip over it. It's just this big giant, like a big puddle you have to jump over. Okay? I like to also, I just think it's a good habit to get into, I like to label my whole. It, it does have some significance, so I just usually like to put a point next to it. You don't have to. And then, just like always, I need to decide if the rest of my graph is on the top or on the bottom over here. So I'm just going to do a little t-chart, and I'm going to pick a point to the left of -2. Remember, my vertical asymptote is at -2, so I want to point to the left of that. So I'm going to get -3, -1 when I do that. So that's going to be down here. So the other part of my graph is simply going to be down in this quadrant. And that's it.